Imagine yourself on the USS Enterprise. You're Captain James Kirk, Jean-Luc Picard, Catherine Janeway. Take your pick, asks you to scan a nearby planet. Could it harbor life? You go down your checklist: oxygen, liquid water, land mass, food. These are the markers science fiction and much of science has looked for during our search for alien life, but is it accurate? The perfect environment in which life can thrive may not be as simple as we initially thought. And it may not look anything like our own Earth. To figure out where to look for life, we can start at large scales. Just like animals, stars change over their lifetimes. The stability and age of any given star can give us a clue into how likely it may have a planet with life in its system. Very bright blue stars that tend to populate spiral galaxies will usually only last a few hundreds of millions of years. In contrast, smaller, dimmer red stars that are common in elliptical galaxies can last for tens of billions of years. The rule is simple: the more massive a star, the shorter and more turbulent its life tends to be. And life will have a hard go at it if the system star goes supernova before anything can even get started. Habitable planets. If we look at our own story nestled in our little solar neighborhood, the very first humans by the broadest definition of the term didn't appear until a few million years ago. If we follow Star Trek's date of 2063 for first contact with another alien race, the Vulcans, that's basically 4.5 billion years between the creation of our solar system and making our first alien friends. It took the very simplest forms of life nearly 750 million years before appearing on Earth. Luckily for us, our quite averagely sized sun has a lifespan of about 10 billion years. This gave complex life ample time to develop. In February 2017, NASA made an incredible announcement. They had detected a system 39 light-years away with 7 exoplanets TRAPPIST-1. 3 of the planets were in the Goldilocks zone. This zone covers the region where liquid water can exist, and depends on the size and temperature of the parent star. All 7 planets orbits a type of star called an ultra-cool dwarf, about 1/113th the size of our Sun. These types of stars can live a relatively stable life for hundreds of billions of years. Simulations of planet formation have also shown that their small size and low temperatures make them more likely to host Earth-like planets. Dedicated telescopes such as the Kepler telescope and the upcoming James Webb Space Telescope are building an impressive catalog of thousands of these exoplanets. Surely, we're bound to find something out there with alien life, but what if we didn't have to look so far? Cassini image showcasing Enceladus plumes of ice water. Molecular hydrogen was detected within these plumes by the probe's specialized instruments. Nisajpulstshi life in our solar neighborhood. NASA made another incredible announcement only 2 months after the TRAPPIST-1 news. The Cassini spacecraft had detected a possible chemical food source for alien life in the form of molecular hydrogen on Saturn's 6th moon, Enceladus, the energy equivalent of 300 pizzas per hour, no less. The future exploration of Enceladus and other ocean worlds such as Jupiter's moon, Europa, and Saturn's largest moon, Titan, is currently the most promising prospect of finding alien life in our own solar system. But our first forays onto these worlds have shown us landscapes very unlike Earth's oceans of methane, surfaces entirely covered in cracked ice, endless underground oceans with no land masses in sight. This puts into question our previously determined list of must-haves to find alien life. That being said, life forms on our very own home planet continue to surprise us by their resilience, robustness, and alien-like qualities. We are always discovering new organisms that thrive in extreme conditions we would have otherwise thought completely deadly. In 2010, NASA made a breakthrough discovery. An arsenic bug microorganism was found feeding off the toxic arsenic in Mona Lake, Calif. These incredibly sturdy organisms, known as extremophiles, may even tie back to the very origins of life on Earth. Unusual life. In 1977, scientists made a stunning discovery at the bottom of the Pacific Ocean. Hydrothermal vents were heating the frigid deep-sea waters and ejecting impressive amounts of chemicals into their surroundings. These dissolved chemicals provide the necessary energy to support bacteria that form the base of the food chain of an impressively diverse underwater ecosystem. Scientists now suggest that ancient hydrothermal vents found on Earth billions of years ago may have populated our world with its very first blips of life. This ecosystem may be very similar to the one hidden at the bottom of Enceladus oceans. These revelations have expanded our very definition of life. If we are to detect life elsewhere in the universe, it's clear we must cast a wide net. As we continue our tireless search for someone or something out there in the great dark void, we need to stop and ask ourselves, what are we even looking for? A survey of the general population will show that we often rely on pieces of science fiction such as Star Trek to guide our expectations of alien life. The great majority of these works portray aliens as humanoid beings. This makes for compelling storytelling. Can you imagine Capt. Jean-Luc Picard having an intellectual showdown with a colony of bacteria? Perhaps not as interesting as discoursing with an intelligent bipedal reptilian creature who happens to speak English. Using a universal translator helps, I'm sure. Evolution, but even Star Trek has been keeping up with the times. The best example of this is the portrayal of Klingons over the years. When they first appeared in the original series, they were merely people with disconcerting tans and facial hair. Klingon in Star Trek Discovery. Hand out as they evolved through the next generation and beyond, they gained facial ridges to differentiate them from humans. This came with a very rich culture and language, but not unlike some found throughout human history. The Vikings come to mind. In the newly released Star Trek Discovery, you'll be hard-pressed to find Lt. Commander Worf's face in the Klingons' much more alien appearance. While this may solidify their role as the Federation's main antagonists for now, we can hope a lesson about accepting beings very different from yourself can be extracted by the series, and as special effects have improved, so too have our idea of what alien life could look like. If we consider the variety of planets and moons we've discovered that could harbor life, we realize that habitable does not need to mean Earth-like. Thus, how can we expect life to evolve exactly as it did on Earth when these alien landscapes are so different from our own? The theory of evolution has showcased with what skill life manages to adapt itself to its surroundings. A more probable depiction of the Klingons could be intelligent octopus-like creatures that thrive on a purely aquatic world such as Enceladus. Alien life may solely exist in the form of viruses with which communication would be impossible, not exactly the kind of fighter Star Trek has historically fed off for plot. It may even take a form we have not yet obtained the capacity to imagine. At the end of it all, when we do finally reach the point of first contact, it may not be as simple as a Vulcan salute.